Welcome to our class CSE 104. If you missed the first three, 101, 102, and 103, that will not be necessary. It might be advisable if you want to take those, but we're going to take right up with where we left off. We're covering my seminar that is normally 15 hours, and we're going through at a snail's pace, covering all the details that I always feel pressed to leave out. Things I always wanted to say but never had a chance to. This is my opportunity here in this class. We're doing this for the sake of my son Eric. It started off just going to be me keeping Eric up to date on the research that I do, because I'm always adding new material, and he's out traveling and speaking, and I'm out traveling and speaking. So ended up a lot of people want to hear about this. So this is what this is, CSE 104. We're covering what's in the middle of, actually near the beginning of our videotape number 6 of our series, and we're dealing now with what about the Ice Age. At the end, the last class from CSE 103 was the beginning of this session on the Ice Age, so you need to catch up just a few things here. Bring us up to speed if you're only taking this class. We're talking about, what about the Ice Age? The textbooks in school will tell the kids and show pictures how that the ice came down as far as, Kansas City, Missouri, down into, mid to southern Illinois. Was there an Ice Age? I don't think there's much question that, yes, there was an Ice Age. If you look at this map, they show the Wisconsin glaciation, the Illinoisan glaciation, Kansas and Nebraska. They'll say there were 4 different ice ages. People have argued about this for years, how many ice ages there were, because as ice goes scooting across the countryside, it scours it, it can scour it down to bare rock. Pushes all the soil out of the way, it can. It doesn't always do that. And when the ice melts back, there's nothing left but solid rock basin where it was. As it pushes along, the ice, like a big bulldozer, will push up a pile of rocks in front of it. Remember when we were in Aunt Lynn's in Mount St. Helens and Mount Rainier? There are what they call moraines all around that region. As the rocks will pile up in front of it, and then when the ice melts back, it leaves this huge pile of rocks. Sometimes they're hundreds of feet high, these piles of rocks, and sometimes they're miles long. All across Illinois and Iowa, you can see the lines on this map here. These are actually moraines. At the end, if it's pushing it along in front of it, and then the ice melts back and it disappears, the pile of rocks in front is called a terminal moraine. Terminal, where it stopped, okay? Usually, after a few hundred years, dirt blows in, and pretty soon you can't see the rocks anymore. It's all, becomes just a big mound. And people build houses on it, and houses, cities built on top of moraines. But if you dig down in 10, 15 feet, you'll start hitting rocks. And sometimes huge rocks, half as big as this house. These monstrous rocks are all pushed in front of this ice. Very frequently, these rocks will have scratches on them, where they've been dragged across another rock. Sometimes the ice will push a big boulder for miles and leave behind a scratch, 50 feet wide and 20 feet deep, a scratch in solid rock. If you ever get up near Detroit, there's an island just off into the Lake Erie called Kelly's Island that is loaded with these scratches. You've got to take a little boat to get out there. Loaded with these scratches from obvious signs of what's called glaciation. Moving ice leaves behind distinctive characteristics. I don't think there are very many people on the creation or evolution side that would argue this point. Yes, there was an ice age. There was ice all the way down to Kansas City, Missouri. The question is, when did it happen? Now, as the ice pushes, it leaves in front of it a terminal moraine. On the sides of it, they're called lateral moraines. Piles of rocks on the side. Remember when we went out there to Washington, we saw, as the ice is bulldozing its way down, real slowly down the valley, rocks kind of automatically go to the middle. If you ever look at a glacier, you'll see a streak of rocks right down the middle of it. It's just by the way it moves. The ice in the center is moving a little faster than the ice at the sides because it has friction against the sides and not as much friction in the middle. Ice flows sort of like plastic, real slowly flowing. It can move real fast. There have been times where glaciers have been seen to move 100 yards in a few days. But normally it's real slow. When we climbed on Mount Rainier, there were 13 glaciers on that mountain. As the ice slides down, it's going real slow. As it goes over hills and down into valleys, cracks open up and then close up. If you ever get a chance to see a time-lapse photography of this glacier, you see these huge cracks open up and then they close up, and it's just amazing to watch over, or they can take 6 months and compress it into 5 minutes for you, Those cracks are 200 feet deep, you know, this wide, maybe this wide, 200 feet deep. Sometimes you get a crack, say, this wide and 150 or 200 feet deep, and it snows real heavy, and it's enough snow that you can't see the crack. There's 6 inches of snow. You're walking along, pshoo, disappear down into what they call a crevasse. As we were climbing Mount Rainier, the guides take us up there, and you take these routes to get up to the top of Mount Rainier. These guys are checking carefully for these crevasses, and everybody's all roped together, and you're spread out, you know, 20 or 30 feet between each person. In case somebody falls into a crevasse, the rest of you, you know, dig in, and his rope goes tight, and then you can pull him back up. But it's extremely dangerous with these cracks in the glaciers. Who cares? Anyway, yes, there's no question the Earth had glaciation effects. As the ice melts back, then, it leaves behind very distinctive features. For one thing, a mile of ice is pretty heavy. It presses down on the ground, and once it's gone, the ground actually lifts back up, sometimes many feet. It is estimated that if all the ice at the South Pole were to disappear, Antarctica would lift up probably 2,000 feet. Just the weight would be gone. I mean, if we parked a freight train in our yard, it would dent the ground down a little ways. Or what if we parked a mile of ice? You know, what a gallon of water weighs. Imagine a mile of it. As the ground lifts up, it's called isostatic rebound. The ground lifts up as the pressure is gone. As it melts back, especially across places like Wisconsin and Minnesota, it left behind thousands and thousands of lakes. Have you spoken in Minnesota? I've preached a dozen times in Minnesota. Yeah. They call it the land of 10,000 lakes and 20 billion mosquitoes, because most of these lakes are pretty shallow. It's places where the ice melted back, the ground would lift up unevenly, and sometimes just places are just trapped. Or if the ground isn't quite even and it rains, the water's got nowhere to go, it's going to fill in a puddle. So more like giant mud puddles, because it's pretty flat up there. So yes, there was an ice age. The question is, when was it? And how many were there? Creationists generally fall into two camps on this ice age question. I believe the evidence indicates, and we'll cover this, my theory on this in this class, that the ice age caused the flood, and then probably lasted for 200 years after the flood. But that's what started the flood. The other group says, oh no, the flood started the ice age. And I always ask them, well then what started the flood? Well, we don't know. You know, okay, I don't either, but I think the theory that we're about to share with you, called the Hovind theory, makes as much sense as any I've heard, and it's a combination of many other people's theories. It's nothing original with me. So I don't think there's any argument. Yes, there was an ice age. The question is, when was it? If you took enough water out of the oceans to freeze and cover the North Pole clear down to Kansas City, you know, with a mile-thick layer of ice, that would lower the oceans by hundreds of feet. Just common sense. You know, you take all that water out, freeze it, stick it on the poles. The oceans are much lower, which makes the continents much bigger.
Do we know much about Canada, and does it show the same effect?
Canada shows effects of ice age almost everywhere. Matter of fact, you notice around Denver, Colorado, you can see there's a blue spot on this map. If it's on the previous map, it doesn't show. It's interesting, when they dug into some of the mountains in Denver for, I think it was for NORAD, I don't remember the story now, maybe it was just a gold mine, the ground is still frozen when you go way down inside. Really strange. Something happened. Mom and I were in Alaska when I was preaching up there about a year and a half ago, and we went on a little cruise boat for a couple hours out to see the Portage Glacier, where the ice, when it reaches the edge, it breaks off, you know. Sometimes big chunks break off. Sometimes little chunks break off. One danger is when the ice breaks off, everybody's standing there watching, all of a sudden, boom, drops down into the water. Well, what happens to the water? Whew, big wave, okay, swamps the boat and everything else can happen. Plus, sometimes the boat will go out there and hit these ice, just like the Titanic. I mean, that's what sunk it, you know. These are smaller icebergs generally, but sometimes huge ones break off. Icebergs, big ones, have been seen floating around for 5 years before they melt. There has been serious talk of getting icebergs and dragging them down with boats to water the Sahara Desert, or to water some of the Arab countries. You know, they got nothing to do with their money. You know, they make all the money from that oil. So let's get a bunch of boats and drag an iceberg down here. Let it melt. It would be fresh water. Anyway, Mom and I are on this little cruise boat going seeing the Portage Glacier, and I'm up on the deck talking to this guy standing there. We're watching the icebergs. The process when they break off is called calving, like a cow has a calf. Icebergs have a calf. Glaciers have a calf called an iceberg. So we're watching these chunks break off, and it's such an awesome sound, and you got to see it to understand it. And I asked the guy, so what do you do for a living? He said, well, I work in the oil field up in Barrow, Alaska. Now, Barrow, Alaska is way at the top of Alaska. There is nothing there. Not a tree, hardly a blade of grass. I mean, just nothing. It's way inside the Arctic Circle. So they will get, several months of pure darkness. And during the summertime, several months of 24-hour sunlight. Okay? I said, you work in the oil well, huh? I said, do you ever find anything unusual when you drill? He said, man, we find the strangest things. He said, just 2 weeks ago, the guys were drilling down for an oil well. They drilled through 1,000 feet of solid frozen ground called permafrost, permanently frozen. The top few inches thaws out in the summer, but then everything underneath is frozen, permafrost. He said, here we are drilling down 1,000 feet, and they started bringing up pieces of wood. And so they started saving the pieces of wood as they brought them out, because they always check and see what they're drilling through. They save the pieces and try to reassemble the core on shore, on land, so that they can tell what formation, are they going through sandstone or limestone or shale, or what are they drilling through. He said, we began putting this together. We drilled straight through a tree that was standing up, and it was 300 feet tall. Well, did you ever get up and see the redwoods or sequoias when you were out in California? Okay. The tallest tree in the world today that's known is the General Sherman tree in north of San Francisco in the redwood forest. I think it's 320 feet. That's the world's tallest tree, somewhere close to that. You get up to Barrow, Alaska, there are no trees, nothing. I mean, it's just like a desert almost, okay? Here they are, 1,000 feet underground, and drilled straight through a 300-foot tall tree standing up. Now, just simple statistics would tell you they probably didn't hit the biggest one. I mean, they might have, but the chances are pretty slim. Several times I've talked to people who work in the oil well up there. One guy gave me this years ago. Very few people I've let see this, and even fewer people touch it. This is some of the frozen wood that was brought up from 1,000 feet below the ground in Barrow, Alaska. It is extremely fragile. Every time you touch it, you lose pieces of it. But I'm going to let you guys hold a piece of freeze-dried wood. Eric, if you'll get this and pass it around, it'll crumble like powder if you just bump it. He said, Mr. Hovind, we were bringing up frozen wood, and of course then it thawed out in the warm temperature. He said, it's freeze-dried. Here, I got some for you. That is freeze-dried wood from 1,000 feet below the surface in Barrow, Alaska. He said, we drilled down 1,000 feet, and then we drilled through a layer of wood, frozen wood, several hundred feet thick. Well, what happened? Something was different up there at some time in the past, okay? The question is, when was it? Now, to the evolutionist, of course, well, this was millions and millions of years ago, and the continents are moving around, and the North Pole used to be at the equator and had a big force, and it slowly drifted north and it froze. Well, maybe so, but I don't think so, okay? I think there's a much more logical theory. That is actual freeze-dried wood from 1,000 feet under the ground in Barrow, Alaska. So this well driller said, yeah, we drilled the same thing. He said, we drilled straight through the top of a tree, 300 feet. First of all, because of the angle of the earth, it gets very little sunlight. The further north you go, the slower trees grow. Shorter growing season. I was on the airplane yesterday coming back from wherever I was, and I sat next to a guy who works in paper mills. He makes the machinery for paper mills. And I've toured many paper mills. I toured one in Port St. Joe down here. And I've talked a lot, I sit by a lot of people on the airplane who are in paper industry, because there's a lot of that around here. And I always talk to everybody I sit by on the plane, or try to. And paper down here, you can plant a tree in Florida, and it'll be big enough to cut to harvest in 30 years. I talked to a guy in Canada who worked in the paper mill. He said, yeah, it takes 60 years to get trees up to harvesting height there. They grow slower, a shorter season. The further north you go, the more this becomes a problem. When you get up into central Alaska or further north, I mean, there's incredible trees in southern Alaska. But the further north you go, the shorter the trees get. Until you get up close to the north slope of Alaska, the trees get about 1 inch tall. They grow up and they grow out like a bush. They spread out. They just... Because the sun never gets up very high. The sun is always, just right at the equator, or right at the horizon, And the sun comes up over here, and goes down over here. When Mom and I were up there, it was so neat watching the moon, because, the moon would go up and go down. It really never did get over your head, And it's really strange. But anyway, this trees get about yay tall. And they spread out more like a bush because they can absorb more sunlight. Well, how do you get a 300-foot tall tree at the North Pole? Very few people would argue with the fact that something was different at some time on the Earth's surface because there are enormous trees near the North Pole. At the South Pole, you find the same thing. Admiral Byrd, one of the first guys, maybe the first guy, I don't remember now, to get to the South Pole back in 1927 or something like that, he reported seeing frozen palm leaves, palm fronds, under the ice near the South Pole. Well, there's a few problems with this, okay? There are no trees growing in Antarctica. Nothing. Especially not palm trees. Okay? We are in Pensacola, 30 degrees north of the equator. We have a hard time keeping palm trees alive up here. Really, further south, they do better. 30 degrees, you go up another 50, 100 miles, really hard. It freezes, kills them. That's 30 degrees from the equator. We're talking South Pole, palm leaves. Okay, well, you look at the evidence. It's a fact. These things are found. North Pole and South Pole have evidence of tropical vegetation. What happened? How did it get there? Now, there's numerous theories about that. The continents are drifting. Okay, it used to be tropical, and Antarctica used to be up here, and it drifted south. Maybe so. Yeah, that is one theory, and that's the standard textbook theory.
I've heard that the ice built up on the poles, and then it just got so heavy that, it tipped it over. Tipped the whole Earth's crust over.
Slid the crust of the Earth. That's what. And see, all of these things are theories that I think certainly worthy of investigation. But we'll give you the Hovind theory, what I think happened. What froze the mammoths? Mammoths are big, huge, hairy, hippie elephants, frozen, some of them standing up. And actually, very few have been found frozen in the standing position. I think about 50 or so, at least that have been researched. Eskimos find them all the time, and they don't care.
Do they eat the meat?
I don't know if Eskimos eat the meat or not. Hans Koopman in Canada, I stayed at his house when I preached up there in Waterloo. His dad worked up on the north slope of Alaska, and his dad said he ate mammoth meat. They found a frozen mammoth, took a chainsaw and cut slabs of meat off with a chainsaw. It's frozen solid. Thawed it out, cooked it, and ate it. According to Hans, his dad said, well, it tasted like it had been in the freezer too long. Well, maybe because it has. It's been in there a while. But there have been reports of a lot of people will feed that mammoth meat to their dogs, no problem. Dogs have a much stronger digestive system. But there have been people who have eaten it. At least I stayed with a guy who said his dad did, and I have no reason to doubt him. Okay, the guy's a good Christian. This is the Beresovka mammoth, one of the first ones actually researched. Now, for centuries, it was known about these mammoths up there. And sometimes you get a very warm summer, and they melt. The ice melts a little further than normal, and so these mammoths, are exposed. When all kinds of theories existed down through history about what these mammoths were. Some people used to teach that they were giant animals that lived underground, like moles, and they dig tunnels, and then they come up, and if they see the sunlight, they die. Well, because the only ones you see on the surface are dead. Well, I suppose that's possible, but I don't think so. Okay, I don't think the mammoths are digging holes in the ground. Kind of tough to dig a hole. Some people teach that the mammoths are designed for cold weather. Well, there are many problems. If you get Walt Brown's book in the beginning, he lists a whole list of problems why the mammoth cannot be a cold weather animal. Just because it had 30-inch long hair doesn't mean it's designed for cold weather. Many animals in the jungle have long hair. If the mammoths lived up where it's cold, an elephant today will eat 500 pounds a day. Where's he going to get 500 pounds of vegetation up there? If he's got to scrape the snow out of the way to get to it. His tusks ought to show wear marks from scraping the snow. They don't. The wear marks there are no more wear marks on the tusks that I'm aware of, none significant anyway. So they weren't scraping snow out of the way to get to the stuff underneath, like a deer, you know, will use his antlers and brush away everything and get to the grass underneath. There just simply isn't enough vegetation up there now to support these mammoths. In 1 year, my understanding is they used to go up and get just the tusks to sell for ivory. Ivory used to be what they used to make keys on piano. That's why they say he's going to tickle the ivory. You know, it's not ivory anymore, it's plastic, but it still sounds better to tickle the ivory than tickle the plastic. And ivory was made for all sorts of jewelry and everything like that. They would go up and get these tusks because they're, you know, they're this big around and 12 feet long. Solid ivory, worth a fortune. You could spend all year hunting around and find 2 of them and pay for your year's salary, you know. So they find these mammoth tusks. In 1 year, my understanding is they took out 20,000 pairs of tusks. Most people estimate that probably around the polar region, 5 million mammoths perished. Now, some good friends of mine, like at ICR and groups like that, they think the mammoths froze after the flood. Well, I have a very serious objection to that.
How are you going to get 5 million?
Yeah, there's only 2 mammoths on the ark. It takes a while to get more mammoths, you know. And it would take a long time to get 5 million of them, okay? You figure they're pregnant for 2 years, at least if they're like an elephant. Elephant's pregnant for 2 years. So this is a long, slow process, getting 5 million of them. And then the other problems are they suffocated. The ones that are able to be investigated, they didn't drown, they suffocated. Get the air on here, would you, Becky? You know, flip that air conditioner over. These red dots on the map indicate where frozen mammoths have been found. The yellow dots indicate where frozen rhinoceros have been found. Frozen woolly rhinoceros. Now, if you look right at the number 140 degree mark there, it goes right through the islands called the New Siberian Islands. On the New Siberian Islands, there have been reports that there are so many animals frozen up there. You can hardly touch the ground when you walk. You're always walking on frozen animals or frozen bones. Frozen bobcat, frozen lynx, camel. I can't document now where I read it, but I know I read it. I'll have to go back and find out where now, because somebody will question me on it. But they found a frozen camel, or the skeleton of a camel. I think it was dried out or dissolved enough, decayed enough. 15 feet tall. First place, camels don't get 15 feet tall. Secondly, they don't live near the North Pole. What would a camel do up at the North Pole? Something was different. Now, why? What happened? We're going to try to explain that here. What froze the mammoths? So here's the things we need to consider. They're frozen, some of them standing up. Not all of them. A few are frozen standing. All you need is one, really, to bring up the question of how did this happen. There's undigested food in their mouth and stomach. Now, some people teach that there's undigested buttercups. There have been reports about that, and the skeptics will jump all over that and say, oh, no, they didn't find buttercups. My understanding is they found buttercup seeds. And there have been all kinds of arguments of when these mammoths died because they analyze what's found in their stomach and what time of year does that grow. If they find buttercup seeds, well, when do buttercups produce seeds? It's only a certain time of the year. Buttercups are a little flower. So by checking what's in their stomach, and some of it in their teeth still have grass, they didn't even finish swallowing their last bite. And they froze. They're not all found this way, but a few have been, okay? They died of suffocation. And there are numerous different ways that they can tell they died of suffocation. Walt Brown has a great section on that in his book. You ought to read that technical section on what happened to the mammoths. Now, his theory is slightly different than mine. Same general concept, but a little bit different idea of what happened to the mammoths. The small ice crystals in the blood indicate they probably froze in less than 5 hours. If ice freezes real slowly, the crystals grow big. If you take water and freeze it real fast, the crystals are very tiny. Like when you make rock candy. I don't know if we never did that, did we, growing up? You take sugar and put it in water and boil it. And as you keep it boiling and boiling, you just keep adding sugar until it won't dissolve anymore. The hotter you get it, the more sugar it will absorb. It'll go way beyond the saturation point. Cold water won't dissolve much sugar. That's why if you make iced tea and then add the sugar, it falls to the bottom. It won't absorb it. But if you add the sugar while you're boiling the tea, like the people in the South know how to do, how to make the real sweet tea. Them Yankees don't know how to make it, stuff up there. They add the sugar later. No wonder it tastes terrible. But add the sugar while you're boiling it. You can take water and boil it and just keep adding sugar. And if you see it collecting on the bottom, raise the temperature. You get what's called a supersaturated solution, beyond the normal saturation point, by simply heating it. Let's just say this glass of water would normally hold 3 tablespoons of sugar at room temperature. Well, if I boil it, I can get 6 tablespoons of sugar to dissolve. If I just keep it getting keep it real hot, I might get 7 or 8 tablespoons to dissolve in there. Then you can take a pencil, lay it across the top with a string hanging down, or several strings down into the solution, and let it cool down very slowly. As it cools, the extra sugar is going to have to crystallize. Because at room temperature, it's only going to hold 3 spoonfuls, and I've got 7 in there. So where's it going to go? Well, it'll crystallize to anything that it can touch. So it'll start to form crystals on the string. Rock. Yeah, add some food coloring. Rock candy. You can buy it stores all over, you know, rock candy. That's what it is. Now, if I let it cool down very slowly, let's say I let the temperature drop 1 degree per minute, I'll get big crystals. If it drops 5 degrees per minute, I'll get small crystals. So by looking at the size of the crystals that are formed, you can tell how fast it froze. And the ice crystals in the blood of the mammoths are real tiny, which is a very, I think, pretty airtight proof that they froze very rapidly. The other thing that tells us they froze quickly is the food in their stomach would continue to rot after the animal died. I mean, hydrochloric acid works whether his stomach acid doesn't know he's dead, right? Nor does it care. It's going to keep doing its job. It's going to dissolve the food. And yet the food is not dissolved. So if you have these problems with the small ice crystals and undigested food, then you have to conclude they froze extremely rapidly. We talked to a guy who shot a deer, or hit a deer one time with his car. No, hit a moose. Where was that? In Maine. Okay. He went back the next day because he thought he might have killed it. He hit it at night. He hit it pretty hard, but he was able to drive on. And he went back the next day, and sure enough, he had killed the moose. And the outside 6 inches of the moose had frozen because it was like 20 below zero. But when he cut into it, the inside had begun to rot. Well, the body heat's trapped. The ice on the outside makes an insulator. It freezes from the outside in. So it traps the heat. Just in 24 hours, it spoiled the meat because of all the heat. So when they kill these moose, they cut them open and cut it in pieces so it freezes from all sides. Okay? Well, in order to freeze an elephant all the way to the center in less than 5 hours, you have to get it in something really, really cold, like 300 below zero. Walt Brown says 150 below zero. He may be right, I don't know. But the people I called, Bird's Eye Frozen Food people and others, said you would need about 300 below zero in order to freeze an elephant in 5 hours. Remember the liquid nitrogen we had here, you know, how fast it freezes a hot dog or a banana or stuff like that? That's about 312 below zero, I believe, is the temperature for nitrogen, liquid. The coldest temperature ever recorded at the South Pole was 127 below zero. I just saw something on the news the other night. They broke the record, 129 below zero or something like that, you know. Big deal, and who cares, right? That cold, it doesn't matter. The movie, or the book by Jack London, To Build a Fire, you know, where he's out there freezing to death, you know, and he said you can tell how cold it is if you spit and it freezes on. As soon as it hits, it freezes. It's about, 50 below. And he was spitting and it was freezing in the air before it hit the ground. So it has to be 75 below, somewhere around there. But if you spit and it freezes when it hits the ground, it's time to move south. That's my thinking on the situation. All right. Anyway, the frozen mammoths, if it takes 150 to 300 below zero, we have to explain, since it never gets that cold on Earth, something had to happen. So I'm going to lay out all the different facts that I think need to be explained, and then give you my theory, which I think will explain why I've selected this theory to explain, try to explain all of these things. I call it the Hovind theory, so nobody else gets blamed for it, in case I'm wrong. And I probably am wrong on some things. But I was strongly influenced as a young Christian by a video that I saw. Actually, it was just a film strip with a tape recording that goes with it by Don Patton, The Biblical Flood and the Ice Epic. That's where I got the beginning of this idea. I said, wow, that makes sense. And I've read lots of books by Henry Morris and all these guys, and I really admire their work. And I've tried to put together what I think is a coherent theory, and I really like Walt Brown's, even though he disagrees with me on a couple things. I think his hydroplate theory is very logical, reasonable, well laid out. He doesn't explain a couple things, like the giant insects, which I think, you have to have a canopy. I don't see another way to get giant insects. A lot of people have influenced this. John Morris, Henry Morris, Steve Austin, Don Patton, Walt Brown, Carl Baugh. And it's a shame, but many creationists haven't learned to eat the meat and spit out the bones. You can glean something from everybody. Okay, I learned things from Hugh Ross. He's got some amazing articles. Now, I disagree with him on just about everything, but there's some things I agree. I've learned things from Jehovah's Witnesses. You can eat the meat and spit out the bones. I mean, it's not that complicated. You can learn something from everybody. So, some people, if they don't like one thing about one person, they blackball them from then on. You're no good. Nothing good can come out of you. Like they said about Jesus, can anything good come out of Nazareth? My theory is slightly different from any other that I've seen, that combines aspects of many other people's theories. I must bear the responsibility if it's wrong. I'm going to review some things about science, or maybe it'll just be teaching the first time if you never knew it. And then we're going to try to explain some things, like fish fossils found in diatomaceous earth by the trillions. I've got a block which we'll show you later when we get to that. It has probably 30 fish fossils in 1 square foot. What happened? This is a piece of shale. When they drill down into this shale, oftentimes they find oil-bearing shale. You can actually see in the sides of this, oil was dripping out in a few places, right here. And you can see a clear impression of a fish that has been pressed and turned into oil. Wow. Pass that around. Be careful. We'll try not to touch the fish part so it doesn't wipe the oil off. There's the fish. He turned into oil by the pressure. What happened to this world? Why do we find petrified clams and snails and seashells on top of Mount Everest? Something strange happened on this world. Okay? The inverse square law is the first thing I want to explain to you. If two bodies are attracted to each other, like, say, the Earth and the Moon, they're pulling on each other with their gravity. The more massive a planet is, the stronger its gravity is. You can actually get two huge steel balls and park them next to each other, and they each have their own gravity, and they'll pull toward each other. And you can hook up bars on there and hook a spring to it and tell how hard it's pulling, and you can check the force of gravity between two giant steel balls or two big lead balls. They have not a magnetic attraction. Gravity has to do with mass, not size. You can have this room full of marshmallows is not as massive as this room full of lead. Okay? Your mass does not change. If you go out in space, you still have the same mass. Your weight changes. You can be totally weightless, but if somebody came up and pushed you, it would be exactly the same as pushing on Earth in a frictionless environment. A 200-pound tackle hitting a 150-pound end, the 200-pound tackle has more mass, and so he will win in the collision. A semi hitting a Volkswagen in space would do the same as it does on Earth. Smash the Volkswagen. Right. So the mass doesn't change, but the weight does. Okay? Inverse square law says if the distance between two attracting bodies is cut in half. Let's look at the Moon is about 250,000 miles away. If we brought the Moon back into 1/2 that distance, 1/8 of a million miles, gravity is 4 times stronger. The pull between those two planets is 4 times stronger. My dad was an electrical engineer at Caterpillar Tractor Company. He had to design the lighting for factories. And the inverse square law applies with lights. If I measured how much light is on my hand from, how many candle power, which is how they measure, is equivalent to 500 candles. If I move that light in to half the distance, I'd have 2,000 candle power. Inverse square law says if the force of attraction between two objects is inversely proportional to the square of the distance between them. So if I brought the moon back to 1/3 the distance, you'd inverse it, flip it over, and square it. 9 times the gravitational pull. Inverse square law applies when you're dealing with gravity, with light, with magnetism, same thing. How strong is the magnet? It's inversely proportional to the square of the distance between the two magnets, and it works with girls. When the distance is halved, the force of attraction is quadrupled. Now, many fellows have not caught on to this until it is too late. See, I travel a lot. I've been home 7 Sundays, I think, now in 9 years. So when you come home after a trip and you get 10 feet away from your wife, it's like, hello, dear, how are you? You know, when you half the distance, it's 4 times the attraction. When you half it again, it's too late. The force of attraction overpowers all resistance at this proximity. So the secret is stay about 10 feet away and solve most of your problems. Next thing you need to remember, or refresh your mind, or teach you new, is a spinning top behaves in a very particular manner. If a spinning top is hit by something, it will wobble, or a gyroscope will do the same thing. It'll wobble, and it follows a surprisingly predictable pattern. Let's say we got a gyroscope spinning on the table, and we thump it with something, throw a rock at it. And it wobbles over 20 degrees and comes back up. Then wobbles over 15 degrees and comes back up. And wobbles over 10 degrees. As it wobbles, it'll follow a pattern. Now, it may be wobbling, tipping this way or this way or this way. But like the Earth, today is tipped over 23.5 degrees.
Pretty stable.
And the pole is wobbling just a very tiny little bit. Not much. The pole, the line between the North and South Pole, is always pointing toward the North Star. Let's say the North Star is up in that tree someplace, and the sun is right here. As we go around the sun, it always stays pointed to the North Star. That doesn't change. But our tilt in relation to the sun would change depending which side we're on. So if we're over here on this side, we have winter because we're tilted away from the sun. If we're over on this side, we have summer because we're tilted toward the sun. We get longer days. And if we're like we were yesterday, the first day of spring, March 21st, the sun is directly perpendicular over the equator, which means everybody gets 12 hours of daylight. North Pole gets 12 hours of daylight, South Pole gets 12 hours of daylight, equator gets 12 hours, and 12 hours of darkness. Now that only happens for a few seconds, and then we move on, and it starts to get, longer days down here and shorter days up here, or whatever. Actually, it's the other way around in the spring. We'd be on this side now, because as we travel around. So our days are going to be getting longer. So yesterday should have been 12 hours of daylight, 12 hours of darkness. Today is probably 12 hours and 2 minutes of daylight. Slowly gets longer. Now, it gets longer faster closer to the poles. At the peak of summer, on June 21st, the longest day of the year, they're going to have 24-hour daylight. We're not. This circle of 24 hours of daylight slowly grows out to the tropics and then goes back in. This circle, the size of that circle of pure light or pure darkness, either one, same thing happens at the pole, at both poles, opposites. Who cares? Okay. If a spinning top is struck by something, it'll wobble around and follow a predictable path. You can actually graph out, if you made a graph over time, okay, after 2 seconds it was leaning 5 degrees, after 4 seconds it was leaning 8 degrees. If you graph time over angle, you would end up with a wavy line, and you can actually go back and look and determine when it was struck by the wavy line. Okay? George Dodwell, famous astronomer, gathered data from all over the world. There's a lot of evidence that the Earth has wobbled down through its history. From the article here on the website, MSNBC, by Randolph Schmid, Associated Press, he said, scientists studying underwater volcanoes have found evidence the Earth may have wobbled like an out-of-balance ball 84 million years ago, relocating the poles and shifting the location of Washington to the tropics. There are numerous different bits of evidence that tell us the Earth has wobbled. For instance, Stonehenge, the rocks piled up there in England, and the temple Amun-Ra, Napoleon's savants drew this picture in 1798. I think it's been quite a bit more destroyed since then. Indicate that they built this thing so that the pillars would line up on June 21st with the sun. See, if you're really smart and you know exactly where the sun's going to be on June 21st, and you know that's the longest day of the year, or if you know exactly the angle the sun's going to be on the shortest day of the year, which is December 21st, it used to be December 25th. But because the Earth is moving a little, it's now December 21st. December 25th was the shortest day of the year. And a lot of the really smart heathen would build this big temple so that the light shined right through this circle and right through this circle and struck this gold plate, you know, on that day. And they would tell their people, now, I'm God, and if you don't bring me presents, I'm going to make the sun keep going down, down, down until it disappears. But if you bring me all your gold, I'll make the sun come back. They would have all these elaborate ceremonies to have the rebirth of the sun god, and that would happen on December 25th, which is a pure pagan holiday. And here all the Christians today celebrate Christmas. I don't think most Christians know that, and I'm not against celebrating Christmas, but I think you do need to understand it has 100% pagan roots. It's December 25th is a pagan holiday. The Inca Indians and the Aztecs would have all these sacrifices, you know, where they would cut people's hearts out and offer them to the gods. Oh, please bring the sun god back. You travel all over Mexico, you see these suns every place. The plates are made like suns. The clocks have like suns, you know. If you look at a lot of the Catholic statues, you'll see Mary holding baby Jesus, and there's a sun coming up, the rebirth of the sun god. Average Catholic doesn't have a clue what they're in, but when they find out most of their symbols are satanic and pagan, they say, wow, I didn't know that, you know. And the honest, intelligent ones will say, wow, I better investigate this. Others will just get mad at me for even saying so, you know. But even when they see them holding the wafer, you know, that they think turns to the body of Christ, it'll have the little rays coming off representing the sun. It's the worship of the sun god, the pagan religion. Okay? That's another whole long rabbit trail I don't want to chase too far. So, these temples, though, today, do not line up with the sun. But you can tell where the sun should have been to make the temple line up. The temple didn't move. And so they can calculate what the tilt of the earth would have been. Based on that temple, and when it, you know, they say, well, the earth is tilted over 23.5 degrees. It must have been tilted only 5 degrees when this temple was built. So George Dodwell spent years and years and years. He's a famous Australian astronomer. He gathered data of how much was the earth tilted when that temple was built. And by putting together all this data on a chart, he said it looked to him like something struck the earth 4,350 years ago, which is what time our Bible says we had a flood. Okay, we'll take a little break. We'll get into more of that when we get back. Today, the earth is tilted over 23.5 degrees from the line perpendicular to the sun. So as it travels around, we're always tilted 23.5 degrees, and that's what causes our seasons. And that's what causes what is called the solstice shadow. In the summer, the sun is higher in the sky than it is in the winter. Now, at the equator, it'd be just the opposite. In our summer, you know, they're having their winter. And Dodwell said, the recorded tilt of the earth, based on the temples that he studied and the evidence of what the earth was tilted at the time the record was made, says that it made a wavy line of a graph that was the match of a wavy line a spinning top makes when struck by an object. It appeared to him that something struck the earth 4,350 years ago. So just by looking at the graph that he made of how much was the earth tilted and when was the observation recorded, something struck the earth 4,350 years ago, according to Dodwell. Well, that's about the time of the flood. Okay, so we're going to put 2 and 2 and 2 and 2 and 2 and 2 and 2 together here and end up with 16. or 20, whatever it comes out to be. But I'm going to give you all the evidence first to support, and then so my theory will hopefully make sense. This tilt of the earth is what causes our seasons. The first mention of cold weather. Now, seasons are mentioned in Genesis chapter 1, I think. But it's not necessarily referring to seasons as in summer, winter, spring, fall, though it may be. The Bible simply doesn't say. I think it's referring more to the length of the year, a yearly cycle. 1 year is one trip around the sun. The first mention of cold weather, however, is right here in Genesis chapter 8. Now, this is after the flood. While the earth remaineth, seed time and harvest, and cold and heat, and summer and winter shall not cease. Many people think, and I guess I would have to be in that category, that probably there weren't any cold winters before the flood came. If the earth were not tilted 23.5 degrees, you would still get warmer at the equator and still a little colder at the poles, but much less of a temperature extreme than we have today. It'd be just about like springtime all the time. Always 12 hours of daylight, 12 hours of darkness, which would be very interesting because you could tell what time it was without a watch. Where's the sun? It's always in the exact same place. Of course, maybe you didn't care what time it was. Okay, but they could have told. Also, the magnetic field may have been stronger back then, so you could actually tell which way is north all the time. We'll get into that in just a minute. That's an interesting concept. Carl Baugh's got a good book called The Panorama of Creation, where he goes into what he thinks it was like before the flood and some of the neat features they would have, like you couldn't get sunburned with a canopy overhead. You always had the extra air pressure, always full of energy, you know, stuff like that. The first mention of cold weather, though, is after the flood. I think some animals, like polar bears, for instance, seem to be more designed for colder weather. They're very uncomfortable in hot weather. If it's always, say, 70 degrees, then it probably wouldn't matter much. You know, they might want more like 50 degrees at the pole and 80 at the equator, some temperature difference, but nothing like the extremes we have today. Next thing to keep in mind. The moon has craters all over it, but they're not evenly distributed. It's been a puzzle to scientists for years. I mean, if the moon is just getting hit randomly, statistics tell us the craters would be evenly distributed. If you just blast the moon every once in a while, you know, the craters should be all spread out evenly, but they're not. It's almost like the moon was hit in a catastrophe. In a relatively short time, maybe a couple of days, most of the craters were formed. The moon is about 1/4 the size of the Earth, so it would be about like a softball compared to this globe. 250,000 miles away. I think that works out to be 30 Earth diameters. So if this is 1 foot globe, 30 feet away would be the moon, the size of a softball. The moon takes about 29 days to go around the Earth. It also takes 29 days to turn, turning real slow. So the net effect is we never see the other side. As it goes around, it's turning at exactly the same speed, so that the same side is always facing toward the Earth.
Now, over hundreds of years, would that change?
I don't think they've noticed it changing at all. I may be wrong on that, but I think it was the Soviets were the first ones to go to the backside of the moon and get pictures. Might have been the Americans, I don't remember. There was a big race. Who can be the first one to get a picture of the back of the moon? Oh, wow. Spend billions of dollars to get a picture. And guess what? It looks pretty much like the front. A bunch of craters, all right? But there are not as many of the huge craters. The ones on the front are called mares, which is the Latin for sea, because it looked like an ocean up there. The Sea of Tranquility, Mare Tranquillus, was one of the seas that, that they landed in. The craters, though, are not evenly distributed. They're not evenly distributed on Mercury either. Mercury is much closer to the sun than we are. Earth is 93 million miles from the sun, which is called 1 astronomical unit. And Mercury is, I think, 0.39, if I recall, about 1/3 of an astronomical unit. So it's 1/3 of the way, or twice as close, however you want to say it, to the sun as we are. Mercury gets extremely hot, being that close to the sun, and it's full of craters. But they also are not evenly distributed. Mercury gets hot enough that you would get what's called crater creep. You also get that on the moon. If we blasted went out with a 357 and shot a hole in the mud out here in the yard, it would make little walls on the side. Over a period of time, it would slowly, even if it didn't rain, it would slowly creep back down toward level. Like putting a pile of tar in your driveway, it'll slowly settle out. The sides of the craters on the moon are still real steep. There's been very little time for crater creep, for them to slowly sink out. Now, the moon has a lot less gravity, so crater creep is not near as strong as it would be on the Earth. But on Mercury, with the hotter temperatures, crater creep is more of a problem. The craters should have melted out smooth again. And they're not. Grand Canyon, the Grand Canyon on Mars is actually much larger than the one on Earth. I forget the size, but it's absolutely monstrous. I forget the name of it, too. I used to know. Who cares, anyway? But this canyon on Mars is, scientists have studied this, and in 1998, Scientific American ran a big article about the crater on Mars is proof there used to be water, and they say this formed in a few weeks. Yeah, why can't you go look at... Here you're looking at a planet where there's very little, if any, water. And you can obviously see this canyon formed in a few weeks. You can go to Grand Canyon on Earth where we got tons of water and can't figure out the same thing. Hello, is anybody home in there? It had to form quickly. These canyons are giant, and there's just very little, if any, water on Mars. Some frozen at the poles, I think, but hardly any. Now, Mars is a much smaller planet than Earth, and it's farther away. It's 1.5 astronomical units, so 50% farther than Earth. A quick way to memorize the distance to the planets is to do it with astronomical units. If you memorize the sentence, my very extravagant mother just sent us 90 parakeets, that's the way to know the planets in order. My very extravagant mother just sent us 90 parakeets, or 90 pizzas, or something, okay? Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. Mercury, I think, is 0.39, if I recall. Venus is about a 0.7 astronomical units. Earth would be 1. Mars is 1.5. Jupiter is 5, if I recall. Saturn is like 9, and it goes on out to 39. I haven't studied this in 12 years, but I just remember these just off the top of my head. So you can get the astronomical units and multiply that number times 93 million miles. That'll tell you the distance in miles. But it's easier to memorize as astronomical units. Okay, Mars is farther out. So it doesn't get as hot, doesn't get as much sunlight as we do here. Plus, it's a smaller planet. I think it's roughly half the diameter of the Earth. Earth is about 4,000 miles, so at this scale, Mars would be a little smaller than a volleyball compared to the Earth. 8,000 miles across. Mars is 4,000, right. Okay, half the diameter, which is not half the size of the Earth. It's much less than half the size. Volume. You know, when you're discussing the size of planets or balls, you've got to decide, are you talking volume or circumference or surface area or, you know, diameter? There's several ways you can make...
Surface area be half?
The surface area of a sphere is, let's see, oh, it's been years, 4/3 pi r cubed, I believe. Take the radius cubed times pi times 4/3, I believe is the formula for surface area. So the surface area will be proportional. It's always proportional to the radius. As the ball gets bigger, you get more volume compared to the surface area, which is we'll probably get into later, with why bugs can't get to be huge. Okay. Anyway, next thing to keep in mind for this theory. There's an effect called the Meissner effect, probably named after somebody named Meissner, is my guess. The Meissner effect is when you see a magnet floating on top of another magnet. You put two north poles together, they push away, and if you do it right, you can actually get them to float. There was a game we had when I was a kid. We had a bunch of little magnets with holes drilled through them, and a little stick on a block of wood, and you put the magnets on there, and you try to put them north against north and south against south, and you know they slowly lift each other up. You know, and there's spaces in between. They're all floating on this stick. Now the ones at the bottom are pushed tighter because just more weight. Okay. The Meissner effect is a magnet floating above another magnet. Meissner is a guy apparently who studied it. Japan's trains, the super train that I rode over there when I was there, that travels like 170 miles an hour or something like that. It was incredible, you know. And we're going down this track, and another train came by. Must have been that far away. And here I'm sitting by the window. I said, woo! It scared me half to death. You know, closing speed would have been about 250 or something. You know, don't stick your head out the window. You won't see it again. They use superconducting coils, and it actually, the train levitates. It lifts up off the tracks because of the strong magnetic field, which means no friction. Until you turn corners. They have special wheels to turn the corners, and even those are magnetically. They try to keep it away from the rail. The less it touches, the less friction you have, less to wear out. Now, it takes a very strong electric current to maintain that strong magnetic field, so they still use a lot of power, you know, to do this. But called maglev, magnetic levitation, maglev trains, all right?
So they are using that.
Oh, yeah. It's still not, I don't know about perfected if this is the right word, but it's not real common. I know there's talk of putting one in between Washington, D.C. and New York or Boston, like that, you know, a maglev train. Extremely expensive to do. But it certainly is possible, okay, to do. Anyway, magnets float on top of other magnets. That's called the Meissner effect. Keep that thought in mind. Number 5. Comets are flying around through space, like Halley's Comet, Levi Comet, Shoemaker Comet that hit Jupiter a couple years ago. A lot of comets are flying around. Some come by pretty regularly. Some every few years. Some, like Halley's Comet, every 76 years. You see it once, it's going to be 76 years till you see it again. Very few people will live long enough to see it twice, because they're probably not old enough to know what's going on the first time it comes by. Nobody lives long enough to see it 3 times. But comets are very commonly out in space are simply giant snowballs. They're ice. Some of them are stone. Some are nickel, which is a pretty rare element on Earth. A lot of the comets, though, are very high in nickel content, which is what they use to make nickels. It's also what they use to mix it with steel, mix it with iron. You can melt your iron, mix in some nickel, and it makes the iron more resilient, like they use it for gun barrels. You melt nickel in with the iron, and when the bullet explodes, the metal swells up and goes right back. Otherwise, it would swell up. Next time you fire, it swells up a little more. Pretty soon the bullet's flopping around in there. And it doesn't hold your casing tight. So over the years, they've discovered which alloys do which things. You know, chrome will harden it, and carbon will harden it, and nickel. At Laterno, in Longview, Texas, was Laterno, where they make the huge tractors and stuff, you know. One of the guys that worked with me, or that went to our church, was a good friend of mine. He worked there all day long, shoveling in different amounts of different materials into the furnace for different alloys that they wanted. It costs a lot of money to make it, you know, you don't want to, you could make all your parts out of, you know, pure gold, and the tractor costs a lot of money. Plus it'd be pretty soft, it wouldn't work very good. So like for certain gears, they'll say, okay, we want X number % nickel and X number % cobalt, and, you know, and he would have to, they would just guess it by shovelfuls, you know. It's 4 shovelfuls is like you do when you mix your mortar for cement, you know, for your bricks. And he brought me samples of molybdenum, manganese, cobalt, and also, I don't remember cobalt, but all sorts of different metals, and had them on my shelf in my class when I taught science there, you know. Had a little sign on it, this is a piece of nickel, you know, little bars of nickel. Probably not worth a lot of money, but it was just interesting to have, you know, pure nickel and pure different metals. Many of the comets flying around through space, though, are ice. Just big snowballs. Now, because outer space, away from the Earth's atmosphere, which keeps us nice and warm like a blanket, the Earth's atmosphere keeps us warm, but when you get outside that, it gets real chilly.
Even in the sun?
Oh, yeah. Because outer space is basically 400 below zero. Fahrenheit. When you get to 459.6, you're at absolute zero. As far as we know, negative 459.6 degrees Fahrenheit is called absolute zero. On the Kelvin scale, on Celsius scale, it's negative 273 Celsius, which is the same temperature, or 0 degrees Kelvin. There's another scale, too, by the way. Nobody hardly uses it. I forget what it is now. It doesn't matter. Outer space is somewhere around negative 456 degrees Fahrenheit, is what they guess. There's about 3 degrees off of absolute zero. And so some have argued, oh, this is proof of the Big Bang, this 3-degree background radiation. Because in some places when they look in space, it's a different temperature than other places. Well, ask them how much different. It's 30 millionths of a degree. First place, I'm not sure you can measure 30 millionths of a degree from that far away. Okay, but let's assume they can. What does that prove? That certainly doesn't prove the Big Bang theory, okay? But they call that the echo from the Big Bang. They're just really desperate to support that theory. Anyway, you got a chunk of ice floating around out there through space for hundreds of years or thousands of years. It's also about the same temperature. Real chilly. If it had any heat, it would be dissipating. So these ice balls are flying around, ice comets. Next thing to keep in mind, if you throw a snowball too fast, it'll break apart. You couldn't shoot a snowball out of a cannon. It gets up to a certain speed, it comes apart. There's a long, complicated reason for this. It has to do with how tightly together are the molecules of water or ice stuck to each other, called the tenacity of the ice. How tightly do they hold on? At a certain speed, they're going to come apart. Next thing to keep in mind. The Earth has a magnetic field, but the magnetic field is getting weaker. Since it's been measured, the Earth's magnetic field has lost 6%. In 150 years, it has lost 6% of its strength, since a guy named Gauss measured it. Okay? That'd be a good quiz question. The magnetic field is getting weaker. It's lost 6% in 150 years. The magnetic field is what causes the northern lights. If you can imagine, you've seen it, you put a magnet in a piece of paper and then sprinkle iron filings on it. You know, it makes the little lines, okay, like an apple core. Earth's magnetic field dips in at the poles, and all around the place where it dips in are the northern lights. You get the northern lights, or southern lights if you're at the South Pole, if the sun is having storms. Storms on the sun will send these things down, and that apparently is what causes the magnetic field. If the northern lights are going crazy, you probably are going to get lousy radio reception. You get a lot of static on your radio. When I was a young teenager, before I was even saved, my dad got me interested in ham radio, and I built my own transmitter. You know, Heathkit, put it all together, you know, and transmit, talk all over the world with Morse code. If the sun's over here, the sun's solar wind is pressing the magnetic field in closer to the Earth. On the opposite side, you can see the picture here, the sun's rays are drawing the magnetic field away from the Earth. It kind of pulls it out like a teardrop. So at night, you get better reception. If you have an AM radio, go through the radio during the daytime and count how many channels you can pick up. If you slowly turn the dial, and so let's say you can pick up 25 channels in the daytime. Do the very same experiment at midnight, you probably pick up 300 channels. Because the magnetic field's being drawn away, and there's low interference, and it's unreal how many stations you can pick up. So at night, I could hear stations from Mexico up in Illinois. You could hear them from, you know, a long ways away on a little transistor radio. Little pocket radio, stick your little antenna up and listen to, you know, South America. It's really incredible. Who cares? Okay. The Earth's magnetic field, though, dips in at the poles, and that's what causes the northern lights. Next thing to keep in mind. The pre-flood world was a lot different than it is today. I believe the Bible indicates that there was a canopy of water overhead. I don't know of any other way to explain all the phenomena we see.
What does Walt Brown think about that verse in the Bible? They separated the waters which were under the firmament.
I don't remember his answer on that. We sat at Phoenix Airport for probably 2 hours, had lunch and sat there and talked for a couple hours. Really nice man, very smart man. PhD in physics, retired lieutenant colonel, I believe, from the Air Force, and now spends all of his time working on that one book.
Really?
And it shows. He's on his 27th edition. The book In the Beginning. It gets better every time. You know, I had his 4th edition. I was going through my bookshelf cleaning out, and I found one that I'd gotten years and years ago, and it was pretty bad. I'll go back and look at my original seminar notebook and think, oh, this is embarrassing. We've come a long way with that thing. We're on our 15th edition there, and hopefully that'll keep getting better. Anyway, magnetic field of the Earth is getting weaker. The Earth used to have a canopy of water above. Next thing to keep in mind, who was Peleg? I hate to say this about the Bible, but Genesis chapter 10 is a boring chapter. You're reading through the Bible, you come to chapter 10, you know, all these guys begetting everybody else, and nobody can pronounce these names except Alexander Scorby, okay? He pronounces every one of them just right, okay? It's incredible. So when I go through this, I listen to it on tape, you know, and let him pronounce them all for me, you know. My preacher always said, when you come to one of these names, just say grasshopper and go on, you know, because who knows, who cares what their name was. But the names all have meanings in the Hebrew. It's just really quite a study if you want to get into all that. But you're reading through Genesis chapter 10. It's got all these names, you know. So-and-so begat so-and-so, and he begat so-and-so, and he begat his son, and he begat somebody else. And you come to verse 25. And it says, unto Eber were born 2 sons. In the first place, this is unusual. Most of them, probably all of them had lots of kids. Why does it mention 2 sons for this guy? The name of the one was Peleg. For, that means because, in his days was the earth divided. Interesting. This is one of the few people in this whole chapter that it says anything about, you know. The rest of them, it just gives their name. But Peleg, it says, in his days was the earth divided. And it also names his brother. I don't recall. I think maybe there's one other one in the chapter where it even names his brother. There are any brothers, okay? It says his brother's name was Joktan. Now, Joktan is the Hebrew word that means shorten, to make shorter, to diminish. And Peleg is the Hebrew word that means divide. So here we have a verse that tells us in the days of Peleg, we have division and shortening. Something is made shorter, and something is divided. Doesn't tell us what. Usually they would name their son after some great event, or after, you know, there's a reason for the names in the Bible, okay? Like the Indians, we taught the story. The Peleg means divided, and Joktan means shortened. Well, if you look at the graph in the back of your seminar notebook, the timeline of the different people's lifespans, you see Peleg right there. By adding up the dates, Peleg was born 100 years after the flood. He lived to be 239 years old, and he died. Well, his dad and his grandpa and his great-grandpa lived up into the 400s. His great-great-great-grandpa, Noah, lived to be 900. 950. Noah's son Shem lived to be 600. So you go from 950 to 600, 3 of them for 400 years old, and all of a sudden, 239, 238, 239. Then Peleg's son Reu lived to be 239, and then 230. Then it drops off to 148, and then 205, and that's the last guy over 200, Terah. Abraham, 175. Isaac, everybody's lifespan gets shorter and shorter. King David finally died at 110. He was considered real old. Moses was 120 and considered real old. Today, if somebody's 120, they're real old. But what happened in the days of Peleg? Well, we'll cover that when we get to the Hovind theory. And number 9. The pre-flood world, according to the Bible, had a layer of water under the crust of the earth. Now, this is critical to keep in mind. The Bible tells us in Psalm 24, the earth is the Lord's, and the fullness thereof, the world and they that dwell therein. For he hath founded it upon the seas, and established it upon the floods. What does that mean? God built the earth on top of the water. Now, some people back 500 years ago were teaching, you know, the earth is flat and there's a layer, it's sitting on a layer of water, which is sitting on the back of a camel or the back of a turtle or something, you know. Nobody ever said, well, what is that standing on, you know. Well, we don't know. We can't go that far in our theology. But okay. Actually, I think there was a crust of the earth, maybe 10 or 15 miles of solid rock, and then water underneath, called subterranean aquifers. Mentions it again in Psalm 136. To him that stretched out the earth above the waters. So when God first made the earth, there was a layer of water under the crust of the earth, according to Psalm 136 and Psalm 24. Something was different. We still today have water down in the ground, sometimes huge chambers. You can go down in some of the caves, like Carlsbad Caverns, and go down there, and then they get into giant underground lakes. You can actually go scuba diving. Dangerous thing, pure black, in a cave. It's easy enough to get lost in a cave. Imagine scuba diving in a cave. You got 45 minutes of oxygen, you run out of, you know, just tough. So usually they're very careful about spelunking and scuba diving at the same time. Okay, last thing to keep in mind. Sometimes there are two ways to look at things. How fast was that calf going? Remember that from seminar part 4. I made a decision years ago, I'm going to believe the Bible until somebody can prove it's wrong. Other people have decided they are not going to believe the Bible until you can prove it right. I don't think that's a wise choice, but that's up to them, okay? It's like the atheist that came to the preacher and said, "Preacher, I don't believe anything in the Bible." He said, "If you can prove one verse scientifically, I'll believe it." The preacher said, "Okay." He grabbed the atheist around the head, grabbed his nose, and began twisting his nose back and forth. Of course, pretty soon the blood is pouring down his face. You know, he said, "Man, what are you doing?" The preacher said, "Well, I was proving the Bible. It says the wringing of the nose bringeth forth blood." Proverbs chapter 30. I don't recommend you do that, but it is in there. All right? He proved a verse in the Bible scientifically. So next week when we come back, we're going to give you the Hovind theory of what I think happened to cause the flood, to freeze the mammoths, to cause the ice age, etc., etc. And I think you'll find this at least a plausible theory. Other people think, "Oh, no, it's crazy. It can't happen that way." Well, show me where I'm wrong, please. Okay? Build a better mousetrap and show me how you catch them. I'd like to see that. Thank you. See you.